All right, so today we're in section 8.4. You're learning about negative and zero exponents. What's really important, and one of the reasons I stopped after 8.3 and tested you, is because quotient and product of powers is so important when it comes to this lesson, okay? So you've got extra review on those sections. We've had 2 review days. You've had a quiz and a test, and now you're going to use product and quotient of powers to help you evaluate in this lesson. All right, so it's not that there's a lot of different concepts and different rules you have to learn, but there's so many different ways that we can look at these problems. So there's a lot of different practice problems that we're doing today, but it's all centered around the same 2 concepts, and that's this whole idea of zero exponents and negative exponents. Okay, so I want you to write this down, and as you're writing it down, I want you to see what you notice about raising any number to the power of 0. See what you notice about each one of those answers, and then the negative exponent also. We'll go ahead and explain that in just a minute. All right, so go ahead and write this down. All right, and if you, okay, now I know we just had a conversation about the calculators, but I want you to see for yourself, okay, we're not using calculators, but get them out and just put in any number you want, and raise it to the power of 0. Okay, here I said 5 to the power of 0 is 1, 3 to the power of 0 is 1, y to the power of 0, obviously you can't do a variable in your calculator, but if you put in any number, you can put in 1,300,000 to the power of 0. It's 1. All right? I don't know. At some point, maybe I can do the research on that. But you raise any number to the power of 0, and the answer will be 1. All right, so that's important. You're going to see some of these problems later in the lesson where you have something raised to the power of 0. Okay? So we need to remember that. Now, next rule. So, any negative exponent will flip the base in fraction format. All right, so here's what I want you to see. Before we even do that, the number 6. Okay, let's take the number 6. Does everybody agree that 6 can be written 6 over 1? Everybody agree? A whole number. Okay, so we're going to view a base that's raised to an exponent in the same way. Does everybody agree that 6 squared could also be the same thing as 6 squared over 1? You with me? So what I'm going to say also is 6 to the negative second power is the same thing as 6 to the negative second power over 1. Do you kind of see that progression? It's the same thing. So for all of these, and this is your overall rule for the entire lesson, any number raised to a power can be put into a fraction. You say, well, there's no fraction. Well, then it's over 1. All right, you with me? This is really important. So over here, what we've written is 3 to the negative second power is the same thing as 3 to the negative second power over 1. You with me? So to write a negative exponent as positive, my rule says that you flip the value in the fraction. If it was in the numerator, now it is in the denominator, and it becomes positive. Okay? So a negative exponent you can place in the opposite side of the fraction, and now it becomes positive. So a lot of what we're doing here in this whole lesson is we're trying to write negative exponents as positive. We don't want negative exponents. If there's a negative exponent, we have to get rid of it. How do we do that? We move it to the opposite side of the fraction. That's what we're going to be practicing in the first 2 slides. You ready? Okay, any questions? Move on to some practice problems now. Okay, so 3 to the negative third power. Okay, 3 to the negative third power. Remember what we just talked about. Okay, writing a negative exponent as positive means moving it to the other side of a fraction. Well, do you see a fraction here? 3 to the negative third power? There is no fraction. However, we can put it over what? Anytime it's a whole number, and this is a whole number, you can put it over 1. All right? And here's what my rule says. If the negative exponent, okay, needs to be written as positive, I move it to the opposite side of the fraction. So it was in the numerator, and now it is in the denominator. Okay? And all we're doing here, this is exactly what the slide says. We're practicing, okay? So we're not actually evaluating yet. This is like the step before that. All right? All I want you to do is just practice moving your terms to either side of the fraction to make your exponent positive. All right? Do you see what we did there? It was in the numerator, and now it's in the denominator, and it's positive. All right? So what do you notice about the second problem? 1 over x to the negative third power. Now where's your negative exponent? Where's your negative exponent now? It's on the bottom. So if you want to write it as positive, where are you going to move it? To the top. So now, instead of it being 1 over x to the negative third, now it's x to the third over 1, or you could just say x to the third, right? Because you don't necessarily have to write it over 1. Okay, I want you to try this bottom one on your own. All we're doing here is we're practicing writing the negative exponents as positive. Okay, we don't want negative exponents. We want them to be positive so we can put them in the opposite side of the fraction to make them positive. Yes, y to the fourth power, or you could have said y to the fourth power over 1. I didn't see too many people put it over 1, but either way would have been fine. Okay, so now I want you to try these last two. Okay, same thing. All right, all we're doing is practicing writing the negative exponents as positive. And we understand that we can do that by moving it to the other side of the fraction. We know that if there's no fraction here, it's actually over 1. All right, it would be helpful for you to write that, at least until you can kind of just really get the hang of this concept. So if it's in the numerator, my rule says I can write it in the denominator to make it positive. So it's going to be 1 over 5 squared. All right, any questions? Any questions on that? Now I want to show you, oh wait, I skipped one. Okay, now I want to show you a couple. Again, I'm still practicing writing negative exponents as positive. But now in these 4 problems, what we see are multiple variables or multiple terms within an expression raised to an exponent. Okay, so go ahead and write down these 4. Leave yourself some space in between for us to work it out. Okay, so go ahead and write down these 4 problems. 1, 2, 3, and 4. All right, and we're still practicing writing negative exponents as positive. So we're not actually solving anything. We're just getting rid of those negative exponents. Okay, so now in each one of these, would you agree that not every term has a negative exponent? So like, let's look at the first one. X to the third, y to the negative second. Well, x does not have a negative exponent. Do you agree? Yes. So if I have to write the expression using only positive exponents, the only terms I need to move to the opposite side of the fraction are the ones that have the negative exponent. The other ones can stay where they are. All right, so on this first one, we start off with everything in the numerator, just like we just did on the last slide. Okay, however, this time, the x term stays there. Why does it stay? Because it didn't have a negative exponent. The only term that has to move to the opposite side is the term that had the negative exponent. Okay? So just because you see a negative exponent doesn't mean everything moves. It's only the parts of the term or of the expression that had the negative exponent. All right? Based on what I just said, I want you to do the top right one. Go ahead and do the top right one based on what I just said in the first one. Okay? So on this second one, all right, again, everything's over 1. Which one of these terms have to move to the denominator? Which one? B. Not A or C because they have positive. So I leave them in my numerator. A squared C to the fourth. Can I add those exponents together? Can I add them together? No, because they don't have the same base. One's an A, one's a C. So I just leave them. A squared C to the fourth over B to the third. I only move the parts of the expression that have the negative exponent. All right, let's look at the next one, the bottom left one. You might be able to kind of guess, even though it looks a little different, as to how I could write these. Again, I'm just practicing writing an expression using only positive exponents. I'm not solving anything. I'm just writing the expression using only positive exponents. All right, go ahead and try it. See if you can get it before I tell you what the answer is. Go ahead and try it. Based on what we've learned about how we write the exponents as positive, see if you can come up with the answer. Does anybody think they know it? Possibly? Kendall, what did you get? That's an X, right? X? Yes. X to the third power over Y to the fifth power. Basically, what she did was she took the term that had the negative exponent and she put it up in the numerator. Okay? X to the third over Y to the fifth. All right, let's look at the last one. And this one, I'm going to kind of use this to kind of introduce you to the next slide. And that's basically what we're doing in the next slide is we're actually evaluating these expressions. All right, that's the point that we're going to get to. 5 over 10. Could I reduce that? Could I simplify that? So sometimes you're going to have these expressions where you actually can solve part of it. Okay? 5 over 10 can be reduced to 1/2. Okay? Now, the variables with the exponents, I can't do anything with those unless I know what they equal. But I can write them as positive. So how could I get these exponents to be positive? I can't just wipe out the negative and leave them where they are. Does anybody have any idea what's going to happen to write these exponents for X and Y? How could I write them as positive? A couple people that know. Anybody? Aaliyah, what do you think? How could I get X to the negative second power? How could I write that positive? Would it stay in the numerator? Where would it go? You just had it right on your paper on a different problem. Where do I need to put it, guys? In the denominator, right? I put it down into the denominator, and now it becomes positive. So where is Y to the negative third power going to go? It's going to go into the numerator. Basically, they switch. All right? And the ones understood, you can leave it. That's no big deal. All right? Okay, so evaluating expressions. So now what we're doing is, you understand now, after practicing the first couple slides, how we are writing exponents as positive, and now we're going to take it a step further, and we're going to say, we can actually work this out. So you're going to see a lot of numbers here, all right? 3 to the negative fourth power. And then go ahead and write down the other two. And then we're actually going to evaluate these, but we can only have positive exponents here. We cannot evaluate something that has a negative exponent. So we have to do something to make it positive. So, based on what we just did in the previous slide, how can I write 3 to the negative fourth power with a positive exponent? How can I do that? Aaliyah? Yeah, very good. Put it over 1 and flip it. Okay, so now it's 1 over 3 to the fourth power, and now I can evaluate that. Actually, we've done this exponent quite a few times. Does anybody have it memorized yet? What is 3 to the fourth power?
81.
81. Every time. So that's something you can memorize. 3 times 3 times 3 times 3, 1 over 81. Okay? So there's an answer here. Whenever you see the word evaluate, you're trying to evaluate any exponent you can, but it has to be a positive exponent before you can do it. All right? Well, let's look at the next one. Do those look like fun exponents to evaluate? No. 8.5 to the fourth power. You literally have to multiply it by itself 4 times. But before you do that, here's where product of powers comes in. You have the same base. Negative 8.5 is the base for both terms. Do you agree? So before you start doing all the work, because you have to evaluate this, before you start doing all that work, why don't you use product of powers property? So product of powers says, multiplying the same base, what do I do to my exponents? You add them. So now what is, and this is why writing it down, negative 8.5, what is negative 4 plus 4?
0.
Negative 8.5 to the power of 0 is 1. And now product of powers just made a very, very difficult problem to solve by hand as piece of cake. Okay? So product of powers can be like your best friend, for sure. If you can recognize same base, now if they were different bases, you're stuck with it. You gotta do the multiplication. Okay? But that's where product of powers really can help you. Go ahead and solve the last one now. 6 to the negative 8 times 6 to the 8th power. You have to come up with an answer. You're not writing your answer using exponents. Now, the directions say positive exponents, meaning you can't evaluate a negative exponent. So that's kind of what it was saying, is you have to make it positive and then evaluate. Hopefully that makes sense. Anybody get their answer? What would the answer be for this next one? Robbie, did you get the answer on that one? The third one?
Third one, I got, use product powers to add negative 8 to 8, and then the exponent is 6 to 0 equals 1.
Very good. 6 to the power of 0 equals 1. Who got that right? 6 to the power of 0 equals 1. Okay? Okay, you're doing well so far. All right, what do you see here on this next slide? I heard it. Fractions. So fractions, am I adding my exponents now? No, I'm subtracting them. And what you're going to notice here is when you subtract them, now your answer is going to be negative. But you can't have a negative exponent, so we're going to have to flip it. Okay, so that's what we're practicing in this slide. Dealing with what happens when you subtract them. Because remember, you have to subtract numerator minus denominator. So what happens when you get a negative? All right, go ahead and write down these 3 problems. So we're writing it out. So I really kind of backed off on the last test on actually showing your steps. But here's where writing it out can really be helpful. Write your common base and then numerator minus denominator to show that step. Because now you can physically see 6 minus 8 is what? Negative 2. 2 to the negative 2nd power. Before you can evaluate this exponent, it has to be positive. So what can you do to write this exponent as positive? What can you do, Leah? Put it over 1 and then flip it. Okay? So 1 over 2 squared. Now I can evaluate it to be 1 over 4. Okay? So before I can evaluate, my exponent must be positive. I flip it, and then I can evaluate. All right? Well, this next one presents in a different way because now I have 2 fractions being multiplied by each other. Well, remember our rule for multiplying fractions. Numerators times denominators. Well, 1 times 1 is what? 1. Okay, so what I can do on the bottom is say, yeah, 5 is my common denominator, and then 7 plus negative 4. I can add my exponents. Well, what's 7 plus negative 4? 3. So I have 1 over 5 to the 3rd power. Now I'm ready to evaluate. How do I know? Because my exponent is positive. When I simplify my exponents, it was positive. What is 5 to the third power? 5 times 5 times 5. Close, but 125. 25 times 5 is 125. 1 over 125. Those exponents have to be positive before I can evaluate. Okay? What do you think about this last one? Okay? So when you first look at it, you think, oh my goodness, it's a negative, right? We don't have to be scared of negatives if we understand quotient of powers. You don't have to evaluate negative 3 to the 5th power because you have the same base. Negative 3 to the 5th power minus 6 is what? What's 5 minus 6? Negative 3 to the negative 1st power. Well, I'm not ready to evaluate because I can't have a negative exponent. So what's going to happen to this term? Put it over 1 and then flip it. Flip it. Put it down in the denominator. 1 over negative 3 to the 1st power. Well, anything raised to the 1st power is just that number. 1 over negative 3. Okay? And that would be my answer. That's how I evaluate. So in this example now, I see multiple terms being raised to powers, and I have to simplify it. I am evaluating as much as possible. Okay? Here's what I need you to understand. This goes back to the question Chloe asked in one of the earlier slides. Negative 5x to the power of 0. What you need to understand, guys, is this is negative 5 to the power of 1. There's nothing written here, so it's to the power of 1 times x to the power of 0. Those are separate. Every term within an expression has its own exponent. That's not negative 5x and both of them are to the power of 0. You have to understand that they are separate. Okay, that's why the expanded version of that was so important in the previous lessons. So, what did we learn about any term raised to the power of 0? It's 1. So that is negative 5 times 1, which is just negative 5. Okay? So a number and a variable together in an expression does not mean they're both raised to that power. Okay? So that's really important. All right, now let's look at this one. All right, again, I'm just trying to simplify, but I cannot have negative exponents. So does anybody have a guess as to what I would need to do here? Does the 9 need to move? Based on what I just said, it's the 9. Does the 9 have a negative exponent? No. What's the exponent for 9? 1. There's nothing there. So 9 can stay in the numerator, but what happens to y to the negative 3rd? It's going to go to the denominator. But now look what happens. When I move y to the negative 3rd into the denominator, what do I have now in my denominator? I have same base. Now before, I would have like x and a y down there when I can't do anything. But if I have two of the same base together, guess what's going to happen to my exponents? I add them together. 3 plus 5 is 8. So if you ever run into a scenario where you try to move the negative exponent and you have same bases, you must combine them. Okay, so 9 over y to the 8th. All right, next one. Okay, so here's the reason we put this one in the lesson. Before you start worrying, oh, I got a negative exponent, I need to move it to the denominator, what do you think you would do first? Before you worry about moving your negative exponents, what would you do first, Akari? Perfect. 4 plus negative 7. Do product of powers. Simplify what's in your numerator first. Simplify what's in your numerator first. Okay, so n to the 4 plus negative 7 over 6. Well, what's 4 plus negative 7? Negative 3. N to the negative third over 6. Okay, so is this my final answer? I'm good. Right? No. What do I need to do?
Changes in negatives. It's not there.
Okay, so I just flip the whole fraction. 6 goes to the numerator. Does 6 need to move to the numerator? Does it have a negative exponent? No, the only thing that needs to move is the n. So I move that down, and I'm only left with a 1 over 6n to the third. All right. Okay, so I think that's enough practice for one day. We actually do still have a little bit left, but we've covered enough to where you should be able to do your homework assignment. And we'll pick up here on day 2 tomorrow. We're going to just continue reviewing this. Okay.